assessment for calculus 3. So, in this, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Niazi bin Johari, and today I will present my lab assessment for calculus 3. So, in this video, I will solve the question using the maple. For the section A, plotting the equation, and the section B, plotting the solid, just like the question 1. For the section A, I choose question B, which is I will plot x squared plus y squared plus z squared is equals to 4, and experiment with the variable limits. First, we will use the command with plots, so that we can use the function of implicit plot 3D. And then we insert the equation x squared plus y squared plus z squared for the limit of x from -3 to 3, y and z also. And here is the sphere. If we playing with the limits of the x, y, z, we let x equals to 1 and y equals to 1. From here, we know that the point is inside the hemisphere. So, we can know the z value is not an imaginary number. So, it has a value that can be found. Let's go to, if we substitute x equals to 2 and y is equals to 2. It's already outside the boundary of the sphere. Therefore, we get the imaginary number. Next, I choose question K, which is I will plot y squared equals to 4x squared plus 16z squared, and playing with the variable limits. Now, we'll use with plots as usual, and by using the implicit plot 3D, we'll insert the equation y squared equals to 4x squared plus 16z squared. We will get the elliptic cone surface. So let's play with the limits of the variable. If x is equals to 1 and y is equals to 1, we can see that the point is already outside of the elliptic cone. Therefore, we will get the solution in imaginary number. If we want the solution of z, which is not the imaginary number, we will substitute x is equals to 0 and y is equals to 1. Therefore, we will get the z is equals to negative 1 over 4 and 1 over 4, as we can see in the diagram. Next, let's go to the section B, which is I will plot a sphere that I choose in between the cone and the plane z is equals to 4. So first, as usual, with the plots, since we know that the cone is come from the cylinder, so we will use the cylindrical plotting so that we will get the cylinder in perfect shape when we plot in the maple. Therefore, here is the coding, which is x is equals to u cos v, y is equals to u sin v, and z is equals to u, where u is the radius of the cone. So we will use the command plot 3D and plotting all the x, y, z, and we will get the cone. Next, we will plot the plane z is equals to 4. Since the plane is in a constant form at the z, therefore we will get the plane in the plane of z equals to 4. We use the point prop function to combine both of the diagram in the same plane. Now, as we can see, we need to put a solid, which is I choose a sphere, inside the cone, but below the plane z is equals to 4. So I choose a sphere with equation x squared plus y squared plus z minus 3 squared is equals to 1, which is the radius is 1, and the center at 0, 0, 3. When we combine it, we will get exactly as the question 1. Next, let's plot the solid, which is the sphere, inside the hemisphere but outside the cylinder. By using the same command, but for the hemisphere we use plot 3D because the equation is not in the implicit form. And I add a grid command to make the sphere become more smooth. And using scaling constraint to get the hemisphere shape more properly. Then, I will use the implicit plot 3D for the equation x squared plus y squared plus x squared plus y squared equals to 4 for the cylindrical, for the cylinder. And the limit x, y, z, I just follow the hemisphere limit because we will combine it later. So here is my cylinder. And next is the xy plane. For the xy plane, it is mean that the plane of z is equal to 0. Therefore, we will use plot 3D and we will get the xy plane. When we combine it together, it will look like this. And we want to insert the sphere that I choose. inside of the hemisphere but outside the cylinder and above the XY plane. Therefore, I choose a sphere with a center 301 so that it will be exactly tangent to the cylinder but at the outside and inside the hemisphere. And as you can see, it is already above the XY plane and also not inside, just exactly tangent to the cylinder. So that's all from me and thank you.